right, so here is the deal with law of sines. A lot of you remember it. It's nothing too fancy. In fact, I might show you just a quick example on a previous page. Let me back up a little bit. Well, let me go with what I've got first, and then I'll show you something and how it kind of plays out. It's one of the most powerful laws as far as right triangles, any kind of triangle is concerned. You can actually solve all triangles with law of sines, well, except for the ones you have to use law of cosines on, but we love law of sines. It's particularly advantageous when you have an angle and a side opposite that you know, so that you can set up one of these ratios that you see up above. Notice it's just setting up the sine of an angle, capital A, over its opposite side, little a, is equal to any sine of an angle over its opposite side, respectively. They're all equivalent in that ratio, and that's you know how these things come about. It's initially somebody's playing around with various values and noticing a pattern. So whoever was carving in the sand out in Mesopotamia at some point in time probably saw this pattern and went, I wonder if that's true. And of course then proofs therein would follow. But let's just play with it for now, and then we can get into the dirty details. First thing you want to do, any of these scenarios with triangles, label first. Get them into the triangle. If you can draw it reasonably to scale, great. If not, that's fine. But it helps you kind of get a sense of whether you're within a reasonable ballpark or not if you put it in something that's kind of like the size that it's supposed to be. Now with cool technology out there in the world, you can actually construct actual models that are precise more often, and that's kind of slick. But let's go with this example, reasonably labeled. I have not made it wacky or out of scale. The thing you need is, like I said, an angle and its side opposite that's given. That ratio, you have to know at least one ratio in order to complete, set it equal to some other ratio, and then ultimately solve a proportion. So I got to have one that's known. I got 28 and I got 26. 28 degrees on the side of 26 feet. So that ratio, sine of 28 over 26, set equal to the sine of an angle over its opposite side of my choice. I'll choose this angle C and side C. So sine of 103 over C. To solve this, you got to set the cross products equal to each other. So those are C times sine of 28 and 26 times sine of 103. Those are the cross products. One of the proportions, we know that cross products are equal. So by setting them equal, we can go about solving for C ultimately. So that means dividing away that sine of 28, and it's all calculator from here. So you go to your calculator, type. I usually go 26 sine of 103, enter, and then divide it by the sine of 28. I kind of keep it clean. Helps me keep my pace up as well. You're going to get about 53.96 if you round to two places. That's something that we'll deal with the rounding issues later on, but for now you're just getting started. Be able to find these, and then say, hey, is that reasonable? You know, side B is 26 feet. Is 53.96 feet okay? Ask that question every time you get a value. Now, to get to the next piece, you probably either you already found that angle A is 49, because you know the three angles add to 180, so 103 and 28 combine to make, 131, and then the difference between that and 180 is 49 degrees. How you go about it's your choice. But that's a ratio. Sine 49 over A is an unknown finished ratio, but I do know sine of 28 over 26, set them equal, set the cross products equal, and then I would divide both sides by sine of 28 to isolate A, and that's the length of that side A. Little calculator, and you get about 41.8 feet. Those values, in the context of that triangle, sound pretty reasonable. Always ask, is it reasonable? That's it. That's for law of science. That'll get you going. Now to the next page, I'm going to have to clear out these little pieces here. See if I can get my next page. Do I have another page? I don't even know if it's showing up anymore. Let me add a page while I'm doing this live. I've had some technical issues with my iPad today, but let's do a wee bit of law of cosines, if I can swing it. I hope that works. There we go. Does that fit in your screen? Cool. You guys have the whole formula. This is the page that has law of cosines on it. To set it up, both law of sines and law of cosines have some issues. You're going to run into some problems, things that don't make sense. I actually would love for you to just encounter those right now without me saying much. Your notes kind of allude to some of the issues that arise, but I want you to get there, and then if you can draw a reasonable triangle and kind of deduce what makes sense, I think you're better for it if I let you just kind of tackle it today. The practice problems you have on your assignment will get you into a few kind of messy situations, but I bet you could work it out. But there are the situations where, one, there's no solution, the triangle cannot be made. And then the other one is, you sometimes can make two triangles out of a given amount of information. And so we're going to look at this case 4, which is under the law of cosines page, just to get you going with law of cosines. Again, I would prefer you go out and label a triangle. It's not labeled, so I'll go draw one for you. If I triangle ABC, I'm drawing a horrible triangle, A, B, and C. You can make fun of it all you want. I'm not even there, so you can call me names. You can say other funny things about me. You can make fun of my new car, but you can't make fun of my new car because it's so awesome. Oh yeah, by the way, I don't know who there is, Mr. Coates, or we have to figure out who's covering for my classroom today when I made this video. But Mr. Bennett, I think you are the other. There is, I'll have to show you my new car. I think you guys will appreciate it. The class will tell you all about it. Anyhow, here's one of these crazy scenarios. I can't do law of sines. You know why? I don't have an angle and its opposite side that I can go from. That means, well, I'm stuck with something else. So sines is only if you have an angle and an opposite side that is available. So for me, this is a classic law of cosines, and cosines goes like this. There are 3 different ways you can write it, and it doesn't matter how you go about starting it. So here's my version. I'm going to start with, if you start with the cosine of A, I'm sorry, if you do angle A, there's a funny formula that goes with it. I'm backing up a little bit. Can't write. Angle A, there we go, is equal to little b, hang on. Why can I not write the letters that I want? Sorry for my little typo. Little a, here we go, that's what I wanted, is b squared plus c squared. I'm going to write the formula and then I'll explain everything from here. Minus 2a, I don't know, bc, let's go with that, bc cosine of a. Oh my Lanta, can't get anything to write. Okay, so here it is. Little a is side little a is equal to b squared plus c squared minus 2bc, again, those are a match, cosine of angle A. Now that's one version of it, so if I hit little stop here and record that. If I do B and set it equal, now hang in there, I know you're wondering what's going on and it's not a big deal, I'll explain it all in a minute. Minus 2ac, hey, whatever 2 values you square in the first part of law of cosines, they also show up here after the minus 2, and guess what, everybody forgets the 2, so don't forget that. Cosine and then B. Do you notice that the angle that I choose over here matches the side? The B and the B, big angle B and little side B over in the left match. Or you can choose little c equal to b squared plus a squared and minus 2 a times b or b times a, it's up to you, cosine of, can you think what's coming? Big C. So look at the matches, there's a pattern to this. Inside the function, you'll find that there is the 2 sides that are not on the far left. So if you have little c on the left, b and a are the things being squared, and then they're after the 2ba. So that's the pattern. So you really don't have to memorize much. You can memorize one of these, and then if you think about it, the others are just rearrangements of that same formula. So I like to think of it as these are the sides, the other 2 sides, compared to if I choose A on the left. And then you use them again, there's B and C again. And then the angle is the same, is opposite of the side that you've isolated on the left. After that, you can arrange B and C and A any way you want to. Okay? So there's the beginnings of it. I'm going to get rid of a lot of this stuff so I can just kind of start working with it. Now, in this particular example, I have little a is 12, little c is 16, those are sides, and then big angle B is 38 degrees. If you have an angle that you know, it's probably best to pick a formula arrangement that utilizes all the stuff you got. If you have an angle, you generally want to go ahead and take the cosine of that angle. So that 38, I'm not going to use the formula I've written up here. I'm going to change it to, I'm going to put it in another color. Instead of cosine of A, I'm going to use B here, which means this is a B on the right, which means A is squared and C is squared. Instead of B, I have A here. So the formula just rearranges so that I can use the B that I've been given, and then ultimately that means this left-hand side is B. And hey, coincidentally, A and C, the two values I need for the inside of the law of cosines formula, are available to me, 12 and 16 respectively. So I got 12 squared plus 16 squared minus 2 times 12 times 16. Sorry if that's really tiny on your screen. And this is the nicest case of law of cosines, where you have side angle side is like the ideal law of cosines, because what it ends up giving you is all the sides that fill in the part of the formula here and the angle in between them. If it's not that nice, then you just have some algebra to go about solving for the parts that are missing. It's not a big deal. So from here, you guys can type this in your calculator as good as anybody and find an answer for B. And then when you're done, you say, hey, is that a reasonable amount? Compared to 16 and 12, this number that spits out, is it reasonable? And we'll go from there. Actually, tomorrow we'll kind of reconcile some of those errors that pop up. But this should be enough to kick-start your day. Have fun hanging with Ethan. He's got a fever and not feeling so well, so that forces me to be home and doing some other work, making videos for you, my Drake students, and a few keys that I need to post. So, hey, I'll work, you work, we'll all have a good time. Hang out with that cute little 4-year-old. Talk to you soon, guys.